Hello there, Algebra students. This is Mr. Kashi speaking. With this video, we're going to go through the notes on section 3.5, which is on shapes of graphs. So hopefully you've already done your warm-up and your vocab. There's a lot of vocab terms that we're going to be talking about throughout this lesson, including the first one here. We have line symmetry. Basically, what line symmetry is if we can write a vertical line that basically folds the graph in half. Okay, so if you think about just having a vertical line of some sort, being able to just draw a line, use it to draw a line to fold it in half, and you can see with this linear function here, we don't have any symmetry. But if you come over here and we were to write that line right down 1.5, you can see how that would be folded in half for that. And not only is there a line of symmetry there, but we can actually write the equation of that, which would be x equals 1.5. So we'd say, yes, this does have line symmetry, and it would be at 1.5. Then moving on to two other examples. This one here on the left is called the parabola. So hopefully you can see that this also has line symmetry. If we were to just go like that, where x equals -2. So this would be, the answer would be yes, it does have symmetry, and that line of symmetry would be at x equals -2. And then this one on the right, it has rotational symmetry, but it would not have linear symmetry at all. There's no vertical line that we can draw to fold that function's graph in half. So on to the next one here. This is an example of a bridge, and it says the graph represents the height y in feet that the main cables of a suspension bridge are above the water x feet from the north tower. So basically, if you take a look at the north tower, south tower, and the cables to the left, that picture to the left there, our y-axis is going to be the north tower. Okay, so this is like our y-axis right there. And then it shows on the left-hand side here the suspension bridge cable, and then across the bottom is the distance from the north tower, and then the y-axis is feet. And once again, we can take a look at our graph and see that we have a line of symmetry. And really what we are looking for here is where that is happening. Well, it looks like it's going to be halfway between 1200 and 2400, and so our line of symmetry would be x equals 1800. And we have this this question that says interpret the symmetry in context of the situation. And so hopefully you can see 1800. Well, that's halfway. So we'd say something like halfway between the towers is our line of symmetry. So that's the lowest point. Obviously, it's going to be a minimum there, and it's going to keep going back up because the two towers are the same height. So that's just kind of taking a look at where you might be able to see a graph like that in the real world. Feel free to pause the video if you need to go back and take any notes. All right, now we're going to be talking about some extrema. So a function is increasing where the graph goes up and decreasing where the graph goes down. I want to talk about these two different points. So this is color-coded. It might not be color-coded on your sheet, but we have two different points here where the graph changes from decreasing to increasing, and then from increasing to decreasing. And this would be what we call a relative maximum. A relative maximum would be right here, and the definition would be where sorry about that, where y values go from increasing to decreasing. So our y values are going up, and now they've reached their maximum point, and now they're going down. So on the other side of that, we have what we call a relative minimum. And that would be right here. And that, when you're reading it from left to right, that is where y values go from decreasing to increasing. So they're going down, they get to their minimum point right there, and then they're going up. We're not talking about, we're just talking about these 2 points in the close proximity of the y-axis here. As you can see, we have it going up to infinity on the left-hand side and down to infinity on the right-hand side. We're going to talk a little bit more about that, but relatively, this is our relative max and relative min. Another word that you might hear is local max or local min. That's another term. Local and relative are interchangeable. Then moving on here, we have a function, a graph of a function. It's a parabola, and we just want to talk about when it is increasing and when it is decreasing. So here, this point at the bottom is known as the vertex of the parabola, but for our purposes, this is what we call an absolute minimum. Okay, that is the lowest point that the graph will ever be. So an absolute minimum, and that's where it changes from decreasing to increasing. So here we're going to say decreasing y values, and that we're going to state an inequality. So here it is whenever x is below 0. So here we're going to have x is less than 0. That is when we are decreasing. So we're decreasing all the way to that absolute minimum, and then we start increasing again. So we would say increasing y values when x is greater than 0. Right at 0 it is not decreasing or increasing. That is the point in which it's changing, so we wouldn't say anything like that. I want to take this opportunity for this graph to kind of talk about some function notation. Just to talk about graphs in general, it doesn't matter what the equation is or anything like that. If you're able to take a look at the graph, and we would, let's say we would take a look at this point right here. That point would be 2, 1. And that would be just how we would write the ordered pair. Now in function notation, we would say f of 2 equals 1. So both of these things represent that point right there. So another example, just writing it in function notation, if we were to say f of 1, well, we would take a look here. We'd go where x is 1, and then we'd go down to where the graph is. So we take this point right there and take a look at the y-axis. Well, that point would be 1, negative 2. So this would be f of 1 equals negative 2. We're just going to be practicing that quite a bit throughout this module. So I just wanted to take this opportunity on this graph to kind of talk about function notation. All right, here what we would say is we have a relative minimum and a relative maximum. Okay, and just to maybe reiterate some function notation, our relative minimum, that would be right here, and so that would be, we would say f of 0 equals 0, or that would be point C. That would be our relative minimum. And then our relative maximum, that would be point B, but in function notation we would say f of negative 2 equals 4, because we have this point right there of -2, 4, but writing it in function notation looks a little bit different. And so then what I want you to do is I want you to write these points in function notation. We have A and D left. So go ahead and pause the video real quick and see if you can write those in function notation. All right, for A, what you would have is f of -3 equals 0. Okay, remember this is the x and that would be the y term. And for D, you would have f of 1 equals 4. Okay, and once again, 1 would be the x and 4 would be the y. And then moving on to end behavior. So end behavior can be a little bit tricky to talk about. And what we talk about is the end. Okay, so we're not talking about these. We're not really talking about the middle. We're talking about right here at the end as x increases and as x decreases. So what we would say is on this end, we would say as x goes to -infinity, meaning as x goes smaller and smaller and smaller and smaller, our graph is increasing in this case. And then down here, we would say as x goes to +infinity, our y values are decreasing. Okay, so this is just kind of saying, hey, we know that the graph is running off. It's running off. We put this arrowhead, but just to kind of describe what that means as we go to the left, as we go to the right, or negative and positive in the x direction. Okay, so if we just had a line like this on this side, going to the left, we'd say as x goes to -infinity, we would say that we are decreasing because we're going down. Okay, and we're talking about that right there. And then on the other side, we would say as x is going to infinity, we are increasing. Okay, we're just talking about that, where it's going to be going from there. Okay, and obviously arrowheads mean that they're going to be going in that same direction forever. And one last example about end behavior. Here we would have as x goes to -infinity, we're talking about here, so that means that we would be decreasing. And as x goes to +infinity, right there, we would be increasing. And then what I would say is let's have a little bit more practice of this function notation. So let's do f of x, or sorry, f of 6, and f of 4, and maybe we'll do f of -2. So go ahead and pause the video, see if you can find those answers to those function notations. All right. So if you find f of 6, we're talking about that point on the graph right there, so that would be 0. F of 4, so you go where x is 4, and then you go down until you hit the graph right there, which that would be a -8. And then when you go to -2, f of -2, you go down, and that also crosses at -8, which is, that's okay to have. You can have two different x's go to the same y. As you can see with their graph, it passes the vertical line test and is still a function. So go ahead and pause or rewind any of the video if you need to go back and take notes, and I will be back in class eventually to help with any questions that you may have.